How you doing, guys? Welcome to another video. Still on topic 10, organic chemistry, volume 8. What are the reactions of halogenoalkanes? Why are we waiting? Let's go. Okay, volume 8, what are the reactions of halogenoalkanes? We talk about nucleophilic substitution and we look at some of the reactions of benzene. The IB understandings are that halogenoalkanes are more reactive than alkanes. They undergo what is described as nucleophilic substitution reactions, and we need to know what the definition of a nucleophile is. We have to talk about benzene and some of its reactions, and we need to be able to write the equation for the substitution reactions involving halogenoalkanes. So why are halogenoalkanes more reactive than alkanes? Well, once we have a more electronegative atom, such as chlorine or one of the halogens, substituted for a hydrogen, the molecule essentially becomes polar, or that bond starts to become polar at the very least. The carbon now is said to be electron deficient because the electronegativity of the halogen is drawing the electrons in that bond closer to the halogen. So it essentially has a positive end and a negative end. So that means that the carbon is able to come under attack by negatively charged ions known as nucleophiles. A nucleophile is an electron-rich species which contains a lone pair of electrons which is donated to an electron-deficient carbon atom. The word nucleophile means it's attracted to a nucleus, and in this case the nucleophile will be attracted to the carbon nucleus, and it attacks that carbon nucleus and then provides its electrons for the bond that will form between the electron deficient carbon and the nucleophile. So for example, chloromethane is converted into methanol when OH- ions in a reaction react with the chlorine to form a nucleophilic substitution reaction. So what happens is the OH-, which is a nucleophile, it has 3 lone pairs of electrons around the oxygen and it's also negatively charged. It sees the partial positive charge of the carbon and it comes in and attacks that carbon. It's a nucleophile, it's attracted to the nucleus. The chlorine will then be able to grab hold of the electrons in the bond and then move off with those electrons. So what we will do is we'll substitute the chlorine for the hydroxide functional group, and then we're left with just a chloride ion. The chlorine atom has been substituted for the OH- group, and that's why it's called a substitution reaction. A nucleophilic substitution reaction because the OH-, the hydroxide ions, are described as a nucleophile. So we need to be able to write equations to show that process. So here we have the reaction between potassium hydroxide and some sort of halogenoalkane. So here we have a halogenoalkane which has a chlorine at the start of the molecule, and then we're reacting that with potassium hydroxide, KOH, because I simply can't go into the lab and get OH by itself. It must come with a cation. So we have KOH, which is aqueous hydroxide. What will happen is there will be a nucleophilic substitution reaction because the OH- is a nucleophile, and it will substitute the chlorine for the hydroxide, leaving us with the byproduct of potassium chloride. Don't think you need to be too concerned about states for these ones, but I've written the states in just in case. They'll just ask you what state does the hydroxide need to be in, and it needs to be as an aqueous hydroxide. So in this reaction we've converted 1 chlorobutane into butan-1-ol via a substitution reaction. In the second one we have the reaction between potassium hydroxide again and then another alkane, halogenoalkane. In this case the halogenoalkane has 3 methyl groups and then a carbon with a chloride. Now that is actually a tertiary alcohol, but it doesn't matter because the same process is going to occur. The chlorine is going to be substituted for the hydroxy functional group, so it's going to take its place, and that will mean we would form a tertiary alcohol. Our tertiary alcohol, we know it's tertiary because it has 3 different groups coming off it and no hydrogens and the hydroxide functional group. If we needed to show that, we could draw it out so you can see we have our carbon with our 3 methyl groups and then our hydroxide as well. So it's a tertiary alcohol because it has no hydrogens connected to the carbon. In the first reaction, we would forming a primary alcohol because the chlorine was at the end of the hydrocarbon. Remember, it's described as nucleophilic substitution because the OH- ion is a nucleophile. Substitution because just like basketball, we subbed one off for the other. Okay, some of the reactions of benzene. Well, benzene does not undergo addition reactions. We can't break down that double bond in the ring. However, it can undergo substitution reactions. That's where we replace one of the hydrogens with an incoming group. So one of the hydrogens can be replaced by what is known as an electrophile. So benzene undergoes electrophilic substitution reactions. Very different to nucleophilic. But the similarity is that they both substitute a group on. Now, an electrophile is a reactant that is themselves electron deficient. They will have a positive charge and see the benzene ring as an electron donor. So they want to get into that benzene ring to feel some of the electrons and have a full valence shell. Now, one of the reactions you need to know is the nitration of benzene, or the putting of a nitro group onto the benzene ring. So we have benzene plus nitric acid, and then in a complex reaction with some sulfuric acid under the right conditions, we actually form the nitronium ion with a series of complex reactions, and that is the electrophile. The NO2 plus with its positive charge, it's electron deficient. That is what will attack the hydrogen on the benzene ring. The hydrogen can then be substituted for the NO2 group, leaving us with a nitrobenzene. The same kind of thing will occur with a halogen. If we want to halogenate the benzene ring, we add a halogen, and then we need to have the right conditions, which is aluminium chloride in dry ether. And that will allow us to substitute one chlorine onto the benzene ring. We can only substitute one benzene at a time. So the difference between alkanes and halogenoalkanes and benzene, one is a nucleophile, the other is an electrophile. So volume 7, what are the reactions of halogenoalkanes? Make sure you know the definitions of a nucleophile for halogenoalkanes, the definition of an electrophile for the benzene substitution, and remember that it's aqueous hydroxide that's required. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe for more, and I'll see you next time.